Have you ever wondered how with just one touch of your fingers, your mobile phones and your computers reacts and performs a given task? Wonder no more, because I will present to you the number systems.
Hello learners, welcome to this session where we're going to discuss the fascinating world of number system. But let's begin with defining what is number system. So simply put, it is a way to represent a number. We use a symbol, a digits, or even a systematic manner to count, to measure, or even perform calculation.
In the context of computers, a number system, also known as numeral system, is a way to represent numeral values using a set of digits and symbols and consistent rules, with the most common being the binary, decimal, octodecimal, and hexadecimal. Let us take a look on our first number system. What is exactly a binary number system?
Let's talk about binary. It's a language of computers, and whether you know it or not, it's working behind every text, every videos, and app you use. So, what is binary? Binary is a number system that only uses two digits, the 0 and 1. It's also called base 2 system because its digits represent a power of 2. Now, you might be wondering why just zeros and ones. Well, computers are built with a tiny electronic circuit that can be either be on, the number 1, or off, or the zeros. So that's it. Two states. And since computers don't understand human languages, they use binary to process and stores everything. So here's a simple example of binary. How do we solve a binary? Or how do we get a binary code?
Alright, so zeros and ones are basically your only units of measuring stuff in binary. So it's either on or off. 1 being it's on, 0 being it's off. So if you have a number like 100110, for example, anytime you see a 1, that value is turned on. Every time you see a 0, that value is turned off. Now, what are the values of these positions? They're going to be identical for every binary number. So you can either memorize this or just have it written down. It's very easy. Starting from right to left, it's going to start with a 1, and then it's going to double each time until you reach the amount of digits you have. So for this example, we have 100110, which is 6 digits. So first you're going to write 6 little digit spots, and then starting from right to left, you're going to label them, starting from 1 at the very right, and then doubling it each time. So we have 1, then we have 2, 4, 8, 16, and 32 finally. So this is all your digits values. And now you're going to write in your actual binary number right below it. 100110. Now, anytime you see a 1, that means that value is part of the number. And every time you see a 0, you basically can ignore that value. And all you're going to do is look at every value that has a 1 underneath it and add them up. And that's it. So this one is going to be really easy. It's going to be 32 because you see it has a 1 under it. So we're going to do 32 plus the 16 and the 8 have zeros, so we don't use those. 4 has a 1 under it, so plus 4, and plus 2, and the 1 is a 0, so we don't use that one. So simply 32 plus 4 plus 2, which is 38. So we just converted 100110 into 38. So that is the binary equivalent number in decimal form.
Without binary, we wouldn't have a computer, the internet, or any of the tech we rely on today.
So that is it for the explanation for our binary system. Next up is the decimal number system.
Binary decimals is extended system to represent fractional values using negative powers of 2. The most familiar number system to us is the decimal system. But what is decimal system? The decimal system, also known as the base 10. So the number system of base 10 is the most commonly used number system in the world. In the decimal system, we have 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Each position in a number represents a power of 10. Now, let's watch the next clip for some example.
Alright, so we're going to start with 41 here. 41. Alright, so how do we convert that into binary? Well, you just got to kind of reverse your thought process that you just did. So first, we're going to think of what is the biggest number I can fit in that is based on these values. So we have these values up here from before. We have 1, 2, 4, 8, 16, 32. But now we have to make sure that we can't go past it. So we're just going to write a couple more. We got 64, and then we can do 128. Obviously, that's too much. So the biggest value we can fit inside of 41, or you can think of which value is less than or equal to the number you're trying to do, would be 32, because 64 is bigger than 41, so we're going to stop there. The next one's 32, that's smaller than 41. All right, so we have a 1 under 32, which means we're going to use that number. Now you're going to take your number, 41, which is our original number, and subtract the 32 that you used. So we have a 1 under 32, subtract it. 41 minus 32 is 9, so we have 9 remaining. So we have to assign 9 more value, or 9 more digits somewhere in this binary. So then you just do the same thing. Which of the following, the left ones, we have 1, 2, 4, 8, and 16 left to choose from, can you fit into 9? And that would obviously be 8. You can't fit 16, and the next biggest one is 8. So 0 under 16, 1 under 8. Do it again. 9 minus 8, we have 1 left. We have to assign 1 more digit, and then we're done with this. And obviously the only digit here that we can assign that's only 1 would be 1. So you just cancel out the 4 and the 2, obviously, because they can't fit in. 1 is the only one that can fit into our final value. Subtract the 1, you get 0. That means you are done. You are done. This is your answer right below here. You have 101001, and that is your binary equivalent of that decimal number 41.
And that is the decimal number system. Another number system is the octodecimal number system.
Alright, let's talk about the octal decimal system. So what is octal? Octal is actually part of the number system. So in this number system, we have already tackled about binary and all the other things. Although binary is much more famous or much more well-known than the octal system, octal is still a very crucial part of the number system, particularly in computing digital systems. So now let's talk about octal. So what is octal? Octal is actually a number system that uses 8-digit numbers, which is 0 to 7. It is also called the base 8 system. So why base 8 system? Base 8 system because each digit represents the power of 8. So now you must be wondering, why is octal system? What's the point of using octal? It is because octal in the early computing is a much more compact way to represent binary numbers. It is because each octal digit corresponds to 3 digital or 3 binary digits. And because of that, reading and writing binary sequences became much more easier. So now let's make an example to understand octal easier. So say for example our binary number is 110101. 110101 is such a long way to write numbers or binary, and instead of writing it all out, we can use octal. There's actually an equivalent of binary to octal in 3-bit section. So we have 110 and 101. In binary, it is 110, and octal it is 6. In binary, it is 101, and in octal, it is 5. So 110101 is in binary is equals to 65 in octal. So it's much easier that way. So now the question is octal still relevant today? Actually, octal is still used in the present times. Say for example, in some computing applications like Unix-based systems, in the file permission of these Unix-based systems, they use octal as a great way to simplify binary numbers, so they will be easier to work with. So now without octal, computing would have been much harder today, and we may not have the efficient system we use in the present times.
And that is it for the octodecimal number system. Now last but not the least is the hexadecimal number system. A hexadecimal number system is a base 16 system composed of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and the letters A, B, C, D, and F. The purpose of hexadecimal number system is to provide a compact and human-readable way to represent binary data in computer science, particularly when dealing with memory addresses, color values, and other data where large binary numbers need to be easily written and understood. It essentially acts as a bridge between binary and decimal systems by allowing for easier conversion between the two, while still maintaining the relatively concise representation. Some common applications for hexadecimal includes the web designs, or representing colors in HTML and CSS by using hex codes. It is also used in computer programming by displaying memory addresses and data values. Also in network protocols, it represents MAC addresses, and in data analysis, it examines the raw data in a more human-readable format. And that will be it for the hexadecimal number system. To summarize it all, a number system is a fundamental aspect of computer science, providing the foundation for how data and instructions are represented and manipulated in computer. The number systems have given their importance in our technologies as tools for data representation, as all data including numbers, text, and instructions are ultimately encoded as binary values or the zeros and ones in a computer. In arithmetic operations, computers perform calculations using these number systems, with binary being the core systems for computation. And in communication, while computers use binary internally, we interact with them using decimal, with software translating between them. And that is the definition and the importance of number system in our digital lives. Thank you for listening, and we hope you learned something.